So, friends, I'm back. Please let me know your availability so that we can start.
Yes, Pawan, we're back.
Yeah, thank you. Thank you, dear.
Yes,
Yeah,
sir.
yeah, very good. Thank you. I'm sorry. Okay. So, we are in the process of fixing the metrics related to various measures, like no matter whether I'm using the type of classification, whatever the classification algorithm I used. So the advantage here is for KNN, naive support vector, decision trees, random forest, logistic regression. For all these things, uh, we can make use of the discussed metrics. And one of the important thing is the base for all these aspects is the confusion matrix. And there we have seen some byproducts related to that. Okay. Now, let me talk about the regression matrix so that we can complete all the revision process of the matrix. Regression also belongs to the supervised algorithms. These are also belongs to the supervised, and the application like the price of the houses, okay, or else a salary of the employee based on okay, salary of the employee based on his experience, okay, which generally give the a kind of so just it is giving some sort of the understanding uh, like getting the value, whatever the value we are getting based on the given inputs we are going to get the value. And out of those kind of the conventions, how we are having in classification here also we are having simple linear, okay, between x and y relation, and multiple linear regression, which is x1, x2, xn, uh, and y relation. This relation we are taking. And most importantly, guys, polynomial, okay, generally we use simple regression, multiple regression, logistic kind of regression. But polynomial regression is something like, suppose I can give some best example here, guys. Maybe, yeah. So companies always having the budget for the right people. Okay, generally, okay, for the right people. Only the thing is, maybe we are getting some 15 to 20% hike. Assume that as a process of the appraisal cycle. But few people are claiming that okay, I have done this certification, I have involved in many projects, and I acquired this skill set within the stipulated time. I deserve more. Okay, definitely that those chances are there. I deserve more. In that particular case, so just our okay, so in the hike process, maybe a maximum budget would be there. Okay, so but for the right candidate, okay, so for the right candidate, definitely we have to accommodate so that to empower the teams. But only our doubt is, okay, this guy is claiming some $2,000 change. Whatever we are offering and whatever he is claiming is having some $2,000 change. That means maybe some amount up to that the managers can refer. But beyond that, we got the information like, okay, you recheck maybe his personal branding or how he has contributed, and you fix up the criteria. And if he's meeting, then we are uh, absolutely okay to offer that amount. Don't look out. Okay, so we are retaining you, like so some sort of the environment like that. So these kind of the situations, guys, where we need to focus on particular offer, like only salary, because there your experience and your skill set, your qualification. all these things are common. All these things are common, but you are claiming more. Yeah, you are claiming more. Then in these particular cases, your polynomial regression is the best option, guys, because we are having some sort of techniques where these techniques barely gives the observation of a relation between x and y, and if it is multiple, multiple independent variables are there like that. But the polynomial regression is focusing on only one kind of the independent variable. Okay, and it is going to approach like so just how it is performing is just it is taking the other parameters. Okay, maybe his personal branding or certificates he has cleared, and his blogs, maybe his research articles. Okay, definitely we may not expect all these things uh, in all the other members, all the members provided. So you are claiming all these, and of course they are evidential. Maybe you are running your own YouTube channel, or your personal branding is excellent in LinkedIn. Like that, there are certain cases, guys. So, but still, these simple and multiple regressions are only observing the relationship between independent and dependent. But whereas your polynomial is something like which is focusing on these kind of the measures, so that if any such kind of the situations you need to think through above and beyond, then in that particular case, the polynomial regression, okay, which is only one independent variable I am taking, x1, x1 square, x1 cube, x1 power 4. Like on the same variable, we are applying some sort of the mechanism. So finally, we are going to achieve the appropriate measures related to this offering of the salary. Maybe more or less $1,500 or $1,800. We can negotiate on that, provided if I'm having that potentiality and company want to retain, then definitely we can achieve that. So if you are considering these kind of the scenarios where you are unable to take the decisions based on the benchmarkings, based on the common practices. So in that particular case, just to go with the polynomial. And some other things, guys, actually, like most importantly, uh, regularization and penalization. So most important technique, regularization and penalization. So just this is also I am posting as a kind of the task, guys, because this particular regularization and penalization is something like which is very much helpful so as to fine tune our algorithmic aspects. Okay, now this regularization penalization, we're having some sort of the algorithms. Already I have said, like just you see lasso, ridge, um, elastic net. So these are all advanced techniques of the regression model, and these particular techniques really gives us some sort of some sort of the understanding, like performance of observation of fine tuning and all the things. And actually it started with polynomial regression. In fact, polynomial regression also, we cannot compare this with simple and multiple. Is a kind of nonlinear technique actually, guys. And some other byproducts actually. So let me see how can I cover in the coming days. Actually, these regression techniques are nothing but the parametric models. What do you mean by parametric model is assumptions in regression. So that means they generally, if you are talking about the classification, we are not assuming anything. We don't assume anything, guys. Like maybe in terms of support vector machine, decision trees, random forest, logistic regression, KNN, naive Bayes. In all these kind of the algorithms, we are not assuming anything. Directly, there is some a model, and with the underlying mathematical or statistical analogy, Just we are going to apply some sort of the mechanism. But whereas if I'm talking about the regression, regression is not uh, non-parametric case. It is a parametric model. Parametric in the sense just we are having some sort of the limitations. Rather than the limitations, I can say that there are certain assumptions in the regression, and based on those kind of the assumptions only, we are going to work out. And this is also just I'm giving to you guys because these things are most important aspects. Okay, so in the discussion of the regressions, okay, just to give a try. So just whatever the topics, bias, variance, trade-off, and as well as the polynomial regression, polynomial regression, regularization and penalization, and then now I am giving the assumptions in regression. So as far as if you consider, if classification I am considered, I directly given the mathematical or statistical formula and the corresponding applications I have given. But whereas in the regression, there are certain topics we need to prepare, like polynomial regression, how it is helping us above and beyond the relationship between the dependent and independent. And then it is providing us some advancements in terms of regularization and penalization, like lasso, ridge, and elastic net, just to have a look on this. L1 terms, L2 terms, something like that. And moreover, the base point for this regression is the assumptions in regression, which is a parametric in nature. Only certain conditions would be there. And before starting or before electing any of the regression models, we are assuming some aspects. So that is how you can refer the assumptions in the regression. Uh, with this, just we can perform we can understand the metrics of the regression, guys. Okay. Now, these regression models, actually, we are having certain aspects related to the discussion of the regression metrics. Out of those, the first one I am giving. Okay, so just observe here, guys. Along with the formula, I have compiled so that in the preparation also you can easily come up. Is the first one R squared. So as the name implies, guys, just if you are talking about the regression, this is a supervised methodology where we are getting some kind of the outcome in numbers and those numerical values, whether those particular numerical values are near to our requirement or not, and some employee demanding more salary above and beyond our scale. So for these kind of the situations, the regression models are tailor-made. Now, out of those things, the most commonly used thing is the R squared. Okay, R squared. So it measures the proportion of the variation in your dependent variable explained by all of your independent variables. Okay, so that means independent variables may be x1, x2, and so on, xn, and it is giving the proportion of, not probability, guys, proportion of these particular things. Just you see, explained by all your independent variables. So measure the proportion of the variation. Okay, because we need that one only, guys, proportion of the variation in your dependent variable. Dependent variable is y, explained by all of your independent variables. That means in x1 and as well as x2, x3, just variation. So this is what you call R squared. It assumes that okay, every independent variable. See, assumption came here. Guys. In none of our measures of the classification, we have not assumed anything. That is what understanding of the classification is simple. The regression we have to assume something. That assumptions, of course, I have given as a task, and I will be assigning the task to some people. But if you feel okay, if you feel any difficulty, no problem. I'll take care about that. No issue. But as a part of the preparation, just I am involving you guys also. So it is assuming that every independent variable in the model, okay, every independent variable in the model helps to explain the variation in the dependent variable. Because I can put like this case. Here the assumption is all independent variables contribute to the dependent. In a indirect sense, it has said, but we are taking in this way, guys. Okay, I'll give you the answer why I have said that point, because I'll clarify in the next measure actually, because there is a problem with the next this measure R square that will be resolved in the next measure. So the equation here is sum of square total as a denominator, sum of square error numerator 1 minus that. So logically, what we are doing 1 minus sigma of 1 y minus y cap. So here the y cap is our model variable, guys. This is y bar is nothing but your mean. So yi minus y bar whole square. This is the denominator. In the numerator, we are having the summation of yi minus y cap. This is the predicted value through the model actually. So just because our intention is to involve every independent variable and how our dependent variable is behaving, or how the independent variable is observing the appropriate variance value, or how it is reflecting in the dependent variable. So that is the aim. Don't worry about the formula. So just observe that this R squared measure is a proportion of the variation in your dependent variable explained by all of the independent variable. What is the independent variable? X1, X2, X3. Like that, we are having various independent variables. It assumes that every independent variable in the model helps to explain the variation in the dependent variable. That means, as this is the assumption, may not be correct also, because assumptions are may or may not correct. Okay? Assumptions are may or may not correct. So, but still, what we are doing, all our independent variables are trying to give some or trying to explain the variation in the dependent variable. And if that is the case, guys, if that is the case, then obviously we are dependent on something. Okay, we are assuming, okay, my independent variable, 10 independent variables are there. All those 10 independent variables are helping me so as to come up with some sort of the analogy. And those independent variables are contributing to my dependent variable with the formula, whatever. Okay. Now we may ask, suppose in the classification metrics, we know that accuracy should be high, and all these precision, recall, we have seen how much value we are getting, that much accuracy we are having. But there is a problem. So whether this R square value should be high or low. So higher the R square value, just observe guys, this is the thing. Whatever higher the R square value, better the model is. So whenever your R square value is high, you can say that yes, my model is good. Now, friends, one more thing. There are certain measures actually, mean, median, and mode. Friends, these are all the measures of central tendency. Your model performance should be greater than at least mean performance of the corresponding values. Uh, that means if our mean is equal to model performance, then how can you say is your model is not greater than mean? How mean is performing to understand the model? Same way, your model is also performing the same, which is not a good model. If your model performance is greater than mean, then only you can feel that okay, this model is good. Friends, at any cost, as a data scientist or as a data analyst or data engineering practice, data engineer practice, never allow less than mean values. So mean has given some value, and if your model performance is not even equal or greater than to mean, then don't entertain that model, guys. You have to do something. Okay, you have to fine tune the parameters, and you have to fine tune the you have to pre-process the data, something like that. But never settle down with the performance which is less than mean. Equal to also bad only, because your model is equivalent to the mean, but there is no significant contribution by your model to the data set or whatever the analogy. So we should be very cautious. Your model performance must be greater than mean. But sometimes, R squared value will negative. Sometimes, if your model is not good at all, if your whatever the data set you have given for that particular thing, if you select the wrong model, there is a concept called underfit. So just this particular thing is opposite to the overfit model. Guys. Underfit in the sense data is complex, but you have selected the base model, which is not trying to explore um, more, to explore more, or to uh, cannot understand the data. Okay, cannot understand the data. So if you refer, guys, actually, this particular underfit model is nothing but the selection of very nominal or very base model rather than selecting the complex model. It always says that some sort of the data which is very complex, maybe image processing or medical diagnosis data, but rather than selecting some random forest or some sort of the logistic regression or else polynomial or else the advanced methods, if you're selecting KNN simply, KNN, what it does, guys, just it is applying the distance measures and it is going to give. Sometimes it is also good only. We are not declining that, but only the thing is, guys, think through if your data is very complex, if your data is very complex, so sorry, guys, I missed out. So this is the network issue. Sorry for that. Yeah. So if you are referencing this particular observation, what it does is just it is making use of the data is complex, but you have selected the base model. That model is not exploring many things and not trying to explore more. And see, one of the important thing is suppose some 30 members are there in the college room. That time. We are talking about classification, regression, and I'm going beyond. Maybe there are few data engineers and some people might be data analysts. They may feel this is a overburden. But for the machine learning or data scientist, it is very quite natural to talk all these kind of things. So that means some of the aspects, okay, that's what I said. This classification and regression, these measures must be known to. This is a basis for everybody. Okay, no matter whether the data engineer or a data scientist or data analyst, for all these guys, definitely all these kind of the conventions are very important. Okay. So now, in terms of this model estimation also, starting from the selection of the algorithm, your data pre-processing, hyperparameter tuning technique, all these things are playing a vital role because without all these kind of the conventions, there is no chance of getting or coming up with the best model. Now coming back, there is R squared. Yes, there may be a possibility, provided if you select the base model, then there is no chance of achieving the better outcome. Okay, so selection of the outcome is also one of the important things. Now, the most commonly used construct is adjusted R squared. So, as I said, R squared, the main problem is, guys, it is assuming that, okay, it assuming that all your independent variables are contributing or they are telling something to the dependent variable. That is the assumption. But that may not be true in all the cases. For that, I'm having the measure of this adjusted R square. At the outset, guys, what exactly adjusted R square is? I may filter some of the people who are really doing well in the sessions. Okay, maybe their interaction, maybe in terms of the presentation. Okay, so the people who are not involving, they may also good. But my perspective is what I am assuming, as they are not participating in the chart, obviously I may see that okay, those things are not, those members are not trying good. But I'm having another option actually. Another option in the sense maybe I'm conducting some assessment two, assessment one, and with that I can sense that oh these guys are also really well, though they are not giving the response in the chat, but still they are working and they are following me. So that particular thing is nothing but some more analysis is required, na? Rather than massively. I can, so to the managers, if I'm saying all really good, manager also feels that oh this guy is not estimating anything. Just roughly he's saying out of 10 members from my team all are good means it's not a reasonable thing like that he feels. But if I'm giving a proper analysis, like if I'm saying like like okay these guys are really well and they are doing well and I have observed the presentation, some evidential kind of thing. Okay, so the vocabulary is good, but still they need to improve communication wise, or collection of the data is good, but they need to format it in a nice way. Presentation skills are good, but timing they have to manage some kind of the feedback. So like that, your adjusted R square is something. It is not massively assuming all the independent variables are contributing to the outcome. Rather, it is focusing on the variables, I mean independent variables, which are really contributing to the empowerment of the outcome, which is really nice, na guys. So rather than depending on all the 30 members or 32 members in the call, if I'm electing only 10 members or else 10 percentage or 3 to 4 members for the research or for the publication or whichever the means, then definitely I can say out of these 32 members, 10 members are really well in the presentation, 10 are good in the explanation, 10 members are really well in the blog writings or research paper writings and all. Like that, if I'm separating, because I cannot say all these members are good in research and publications and all. There is no evidence. But with thorough understanding of those things, I can say some XYZ members are well for this kind of the work. These 10 members are good for allocating these kind of the tasks. So, likewise, adjusted R square also what it does is just it is picking up the independent variables which are really contributing to our model. Hope you got the point, guys. So your model just it is performing well with all the independent variables, but we are not sure that all the independent variables are going to contribute to our model, because practically also it is not possible. Whatever the data or whatever the features we are having, all the features may not equally contribute to our model. But it is always a wise decision. It's always a wise decision to identify selected members. That's what some people become managers. Some may be getting hikes. Okay, likewise because of their hard work and their commitment, guys. You can clearly observe one or two cases may be missed out cases. Those cases always be there. Na? Leave those cases, but believe the standard point. If you are following the standardization and if you are stick to your commitment and stick to your skill set, then definitely we are going to rule the market. No doubt about that. Okay. Now, if you are considering the ask way, just let me go through. I have given enough context. It measures the proportion of variation explained only those independent variables that really affect the dependent variables. Independent variables that really affect the dependent variables. See, guys, in this case, we are assuming that okay, all every independent variable, but here no portion. It measures the proportion of variation explained only those independent variables that really affect the dependent variable. Now, one more point, guys. Here, it penalizes adding independent variables that don't affect the dependent variable. Affect the dependent variable in the sense maybe the value may be getting affected, or maybe the outcome directly may be getting affected. So now here n is the total sample size, p is the number of predictors, r square. Okay, sampling of the whatever the sample r square value, n minus p minus 1. This is the denominator. In the numerator, we are having 1 minus r square n minus 1. So 1 minus of total. R square adjusted only considers R square adjusted only considers the independent variables which are really contributing. Okay, this is a some troubleshooter kind of thing. In our teams also, some people will come to us, and if any issue is there, then they simply help us and disappear. Okay, they don't need any publicity or whatever. Okay, uh, that is one of the important aspects. And we are adding some more points, guys. Like every time you add an independent variable to a model, the R squared increases. Even if the independent variable is insignificant, it never declines. See, here the problem is some people are doing nonsense. Okay, they are not coming to the meetings and they are not really contribute to the team, and still those members are sitting and they are not doing. But it creates some imbalance, guys. But no problem. Okay, so we are having adjusted R square also. Okay, like that adjusted R square monitors the members' activities, and of course whether he is really including in the appropriate aspects, whether he is really contributing, and one day definitely that guy should pay the penalty. There is no, not in our company or any other company. Definitely there are certain observations. Okay, where we generally elect because simply getting into the team won't give any pleasure, guys. Just you need to work and you have to learn that balance must be maintained. Maybe in one day we may not get into the actual thing, but slowly, if you are increasing your capability of learning, then definitely you are going to achieve. Similarly, here in the R squared, guys, simply whether it is performing anything or whether your independent variable really contributing, without verifying those things, your R squared is accepting everything. Though that independent variable is not contributing anything, but still it is entertaining that, which should not be as a measure. Whereas, see, our troubleshooter adjusted R square increases only when independent variable is significant and affects dependent variable. This is the most important measure, most important aspect you can observe. Okay, so if someone asks you what is the distinction between R square and adjusted R square, just you can say R square without any observation. It assumes that all independent variables are contributing. But adjusted R square is not like that. Just it is observing that okay while adding, okay whether it is really performing any benefit to the corresponding dependent variable. Then only it is going to add. And of course, guys, some other measures are also there, like uh, root absolute error, root mean square error, okay, like that. And just if you consider the root mean square error, uh, all the squares, okay, mean of all the squares, and we are applying some root value. That and the name suggests that one only. So yi minus y cap. Here y cap is nothing but your predicted y, guys. Just observe that y cap specifies predicted y, whereas y bar specifies mean. Okay, mean value. So don't get confused. Y cap is your predicted y. Okay, so y bar is nothing but the mean value. Like that, you need to observe. So, and moreover, if you consider the formula related to your root mean square error, so just it is computing uh, the mean value is nothing but average 1 by n sigma equal to 1 to n. So just we are running through 1 to n values. Your actual value minus predicted value whole square. It's some sort of erroneous kind of thing, friends. Root mean square error actually. Error we are computing the values. It is nothing but y test minus y predict kind of thing. We are squaring the error. That squaring of the error is known as okay OLS kind of thing. Okay. So ordinary least square error, which is a great measure of the regression. Again, while revisiting these particular topics, just will be seeing. Okay. Now, root mean square error, it explains how close the actual points are to the model's predicted value. That is pretty understood. Your prediction is y cap, your actual values are yi. And if the error is less, then I can say they are very near. And it measures the standard deviation of the residuals. Standard deviation, SD. Okay, standard deviation. So, and finally, we have seen if R square value is more, then your model is really doing well. But this is talking about the error, guys. If error is more means definitely your model is not doing well. So lower the error, better the model. So lower RMSE value indicates better fit. So these are all common measures where you can observe related to the uh, this regression kind of. Okay, so let me give you the key takeaways without any waiting, guys. So the first thing is just we have seen classification techniques. Okay, and then we observed some measures and metrics, and thereafter now we have seen the model of the regression and measures of regression. Okay, now just there is a differentiation, so we cannot use the regression measures for the classification, classification measures for the regression. Just observe that. And in the next session, guys, so the next session, what we are doing here is uh, just I want to give you the ML Databricks questions, and thereafter your DE Databricks questions. Okay, so along with these things, one or two implementations I will put. Maybe that is a data frame implementation and all. Because once I start with the data frame usage, we cannot go back to the ML discussion. Okay, that's what I am clearing this ML initially. But still, the implementation I am postponing to after completion of the data frame discussion, because that is a vast thing again. Okay, just will take some algorithm and I'll explain with the scikit-learn so that you can have the again revisit of these things. So just we had a discussion of classification and metric and the corresponding measures, regression and the corresponding measures, and yet to see many things: scaffold, grid set CV, and train test split, and then bias variance trade-off. Like that, we're having plenty of things. I'll be covering those things periodically, guys. But in the tomorrow session, just this is the plan. And let me see in the tomorrow session. However, the three members are going to talk those topics also, so that it will be helpful to you to write the Friday evaluation, to attempt the Friday evaluation. That's all, guys. Thank you. Thank you very much for your support. And if you are having any doubts, please paste in the chat window, guys. Okay. So otherwise, we can wind up and meet you all on the tomorrow session. No problem. You need not paste now. Later also, you can paste in the same team. Or personally, you can contact me as well. Okay, with that, just good day. Meet you tomorrow. Thank you very much.
Thank you,
Any doubt?
sir.
Thank you, sir.
Rahul? Okay, man. Okay, okay,
Thank you, sir. Thank
guys.
you, everyone.
Thank you,
Yeah, thank you.
Surendra. Bye.
Bye.
Thank
Thank you.
you.
Bye.
Bye, bye.